Good evening, everyone, and welcome to the webinar today. Thank you for joining us. So today we have with us our guest, Haasine Chandrasekhar, who is currently working at Bosch as a program manager. She's going to be giving an overview on ADAS. So welcome, ma'am, and yeah, the stage is yours. So you can briefly introduce yourself and start with your overview.
Hi, everyone. I'm Haasine Chandrasekhar. I have overall 16 years of experience across automotive and healthcare domains. I'm currently a program manager at Bosch. I lead a team of engineers focused on base software development in ADAS or vehicle computer. My career has technically spanned various functions, including program and innovation management, pre-sales, business analysis, as well as V&V. I've earlier worked as an innovation program manager at new business teams in Bosch India, and I've also led healthcare projects, both services and products. What really drives me at work is the fascinating interplay between technology, business, and the human element. Currently, I'm also diving deeper into the business side of things through the Executive General Management Program at IIM Bangalore. Outside of work, I am also a passionate Bharatanatyam dancer and dabble in photography. These are some creative pursuits that have helped me stay grounded. Hello, everyone. Now, imagine a world where vehicles or cars could actually see, think, and even predict what might happen on the road before you do. Well, that's not science fiction. It's actually happening right now, and it is called Advanced Driver Assistance Systems, or ADAS. A world where technology not only assists drivers, but also saves lives by preventing accidents before they occur. Today, we'll dive into how this game-changing technology is reshaping the future of mobility, making our roads smarter, safer, and more efficient. So buckle up, because this isn't just about cars, it's about the exciting crossroads of engineering, innovation, and the impact that you as engineers can take it forward. I'll go over briefly the agenda of today's discussion. We will start with why automated driving and what is ADAS, followed by different levels of automated driving, understanding levels of automation and SAE classification, fundamental elements of an automated driving system, industry expectations, key skills mindset, overview on ADAS careers, and actionable takeaways. To get started, let's look at some statistics. Now, when we look at demography, the average global age will be 33 years by 2030. That's like 4 years older than today. 68 to 70% of the population will start living in cities by 2050. And there will be 30% more energy consumption worldwide until 2035. And beat this, there will approximately be 150 billion connected things by 2030. Now, when we look at all of these demographics, what we can take cues from is the fact that mega trends actually shape the future of a safe, sustainable, and exciting mobility. Now, why is automated driving necessary, or why do we need self-driving cars at all? Now, 90% of all the car accidents involving injury are caused by human error. Automated driving or autonomous driving to a great extent helps in the reduction in motor vehicle accident rates. Also, we see that over 65 segment growing 50% faster than the overall population. Now, automated driving also helps with the fact that it allows a variety of age ranges to be mobile. Now, predictive driving strategies actually enable higher fuel efficiency and also improve traffic flow. Now, getting into the details of what are these levels of automation and what really is the driver's role here. As you can see in the slide, you can see the progression of automation levels in vehicles, how the driver's role changes as the technology advances. At lower levels, the driver is fully responsible while systems provide assistance. As we move to conditional, when I say conditional, it means assisted, partial automation, conditional automation, high automation, and full automation. As we move up these levels, the vehicle can handle specific tasks without continuous driver monitoring. Like at the highest level, that is full automation as we call it, or even level 5, it eliminates the driver entirely, enabling a fully autonomous driving experience. Now, you'd have heard a lot about automated driving and sometimes self-driving, then there's driverless, and then there's autonomous driving. Now, what is it? Is it all the same? So now let's look at the smaller details, the finer details of automated driving. Specific tasks or functions within the driving process that are automated. So we have something called as adaptive cruise control, which automatically adjusts the vehicle's speed to maintain a safe following distance from the vehicle ahead. Or we have the lane keeping assist, which provides a corrective steering or alerts to keep the vehicle within its lane. When we say automated driving, it means that there is an option for the technology to assist the driver, but it still requires human oversight. Moving on, we have something called as self-driving vehicles. Now, these are actually designed to operate with minimal to no human input for most of the driving tasks. It actually will still have manual controls, but primarily intended to function independently. Now, moving on, we have another category, which is driverless vehicles, which actually means that these are fully autonomous vehicles. They do not require a human driver to be present in the vehicle at all. They're actually designed to operate completely independently. Everything together, this whole spectrum, when we say automated, self-driving, as well as driverless vehicles, all of this constitutes what we call as autonomous driving systems. On, we have something called as SAE, which is the Society of Automotive Engineers, an organization for standards. The SAE J3016 update actually was developed in collaboration with the International Organization for Standardization, that is ISO, which offers refined definitions for the levels of driving automation. Now, here we can see the classification from SAE level 0, 1, 2, 3, 4, 5. As the levels increases from 0 to 5, we see that the cars become more and more autonomous, which means to say that the extent to which a human being or the driver needs to interact or to have the control of the car keeps decreasing. Now, when we see from SAE level 0, 1, and 2, you can see that in this slide, we are talking about what does the human in the driver's seat have to do. Now, when we say 0, 1, 2, it means that you are driving whenever these driver support features are engaged, even if your feet are off the pedals and you're not steering. And what do these actual features do? We are talking about some features like automatic emergency braking, blind spot warning, or even lane departure warning. Now, what is AEB or automatic emergency braking? I'm sure many of you would have heard about these in the cars which actually have some of the automated driving features enabled. Now, this is a safety system wherein automatically the car applies the brakes to prevent collisions. Now, what is blind spot monitoring? Now, this blind spot monitoring is another feature which uses sensors to detect vehicles in adjacent lanes and provides warnings to prevent collisions during lane changes. We also have something called as lane keeping assist, which provides corrective steering or alerts to keep the vehicle within its lane. So as we move from level 0 to level 5, which means that the number of features which are assisting the driver to become more and more for the car to become more and more independent without having any dependency on the driver keeps increasing, which means to say the number of features, autonomous driving features, keeps getting added as we move from level 0 to 5. On here we have more differences outlined when we talk about level 0 to level 5 of the automation, which is technically saying that when we say level 0, it means that it is not autonomous, hands-on, the driver is always in control, system provides assistance in an emergency only. When we move to level 1, here we see that it is still hands-on, the system provides either steering or speed control. Now, level 0 to 2 are aspects wherein the system provides limited assistance. As we move up, that is from level 3 to 5, the system starts taking complete control of the vehicle. Now, when we come to level 3, it is automation in limited circumstances only. which means that hands-off is a possibility. System actually steers and controls the speed. Now, in level 3, eyes off is a possibility, which also means that the driver can intervene or should intervene in emergencies. Now, as we move on, it becomes a little better at level 4, mind off. That's what we call it. And the driver intervention is not needed at all. And at level 5, of course, we are saying the driver off, which means that it becomes a completely driverless car. Now, level 3 is very similar to level 2, but with much higher confidence level, redundancy, as well as performance. Now, some examples of level 1, 2, and 3 is what I'll give now. Now, when we say level 1 of automation, it means that there is a basic driver assist. There is the adaptive cruise control, we have the lane keeping assist, and some examples on the Indian roads, we can talk about Hyundai Creta, MG Hector, or Baleno, which actually have the L1 features. And coming to L2, we have features like lane centering assist, ACC, which I just spoke about. Driver engagement is actually still required. And some examples again are the Mahindra XUV 700. Benz also has its E-Class, MG Gloucester, etc. When we say level 3, autonomous driving beyond level 2 in India still faces a significant regulatory and infrastructure challenge despite advances in technology. And when we say level 4 autonomous, we do not have those cars in India yet. And one of the examples is Waymo, which is already experimented or is already there in certain areas in US. I hope this sort of gave you an overview as to what the levels of automation from level 0 to level 5 constitute. Now, if we have to achieve autonomous driving or automated driving, there are a lot of aspects, sensors, which come into picture. Some of the sensors here I have listed, mainly it is the radar, lidar, ultrasonic sensors. I have tried to give you a short overview of this because moving forward, when I talk about the elements of automated driving, these becomes very important. So I'll touch upon smaller aspects of what the operating principle of a radar is, what are the weather sensitivities, range, resolution, etc. Now, as you can see, when we talk about radar, it uses radio waves to detect the presence, direction, distance of the objects. When we talk about lidar, it actually uses laser light to measure the distances and create high resolution 3D maps of the environment around it. Ultrasonic sensors technically use sound waves to detect objects and measure the distances. Now, when it comes to weather sensitivity, for each of these sensors, it is a bit different. Radars actually operate in various weather conditions, including rain and fog. But when you look at lidar, it actually struggles in adverse weather conditions such as heavy rain or fog. Now, ultrasonic sensors can be affected by ambient noise and environmental conditions as well. Now, range. Range is for radar, it's a long range detection capability. Lidar, comparatively, it has a shorter range when you compare it to radar. And with ultrasonic sensors, it's used again for short range detection and proximity sensing. And when it comes to resolution as well, there is a difference between all the three of them. A radar has lower resolution. Lidar has a bit higher when it compares to radar. And ultrasonic sensors, actually, the accuracy levels are pretty low in terms of resolution compared to both radar as well as lidar. Now, here, when we have to talk about elements of an automated driving system, well, to actually operate for a system, we're talking about a system that will start to operate like a driver. Now, to operate like a driver, an automated vehicle follows three main steps. Technically, one is sensing the environment, interpreting the situation, and acting accordingly. It uses sensors like, as you can see, we have radar, lidar, and ultrasonic systems, and also video to gather data, which is combined with high definition maps and vehicle dynamics to interpret the surroundings. Software algorithms then plan a safe, legal driving path, and actuators handle the steering, braking, and the acceleration. Now, two critical points to emphasize here is that Redundancy. Now, redundancy is something that is essential across all the sensors. Localization, software algorithms, and actuators are really important for reliability and validation. Validation is very important because this must cover the entire system, especially when incorporating aspects of AI to handle complex scenarios effectively. So, what I just spoke about, redundancy and properly understood validation, these two are extremely crucial throughout the sensing, thinking, and acting which happens in an automated driving system. Moving on, we will look at what are the requirements for deployment of automated driving. Here, as you can see, legislation, security, system architecture, surround sensing, aspects of localization, decision making, safety, validation, and release process are the key elements or requirements for the deployment of an automated driving system. Actually speaking, safety is a non-negotiable aspect at all levels. Now, what happens is legislation for automated vehicles varies across regions, and some countries taking progressive steps and others are adopting more cautious approaches. For example, Germany is expanding test areas while California has allowed driverless cars since 2018 itself, provided they meet strict safety and cybersecurity regulations and standards. Now, this actually highlights that the diverse challenges governments face in developing regulations for autonomous vehicles. Security, of course, is also a major concern because as autonomous vehicles are prime target for hackers. Ensuring the safety of automated vehicles is critical for their mass adoption and smooth integration into regulatory frameworks. Now, this process not only addresses safety concerns, but it actually facilitates regulatory acceptance as well. So, when we look at deployment of an automated driving system at any point of time, these aspects or these elements which are listed here are of prime importance. Moving on, you might be curious about how to get into, the industry of ADAS or how to start your careers in ADAS. That is something that I will now cover. So when we look at industry expectations in terms of what are the key skills or mindset that is required, there are four things which I think are very crucial. Of course, as you all know, programming and software development is really important. Python, C, C++ are actually the industry standards. Now, languages are crucial for writing algorithms. It could be for controlling the ADAS function, or it could be for sensor data processing, or for deploying the decision-making logic itself. So what I would suggest you all to do is that you start building small projects like, for example, develop an object detection or a basic simulation to strengthen your coding skills. The next aspect which becomes very important in the current age is data analytics. Now, actually, ADAS relies on processing large data collected from sensors as well as cameras. For this, look at aspects of how you can very well understand things like statistical analysis, machine learning, data interpretation to refine the systems for real world scenarios. Now, practice with open source data sets to understand how data drives real time decisions. The other important or a really major aspect is about system or software integration itself. Now here, ADAS actually requires a seamless communication between multiple subsystems. It could be the sensors, it could be the control units, or the actuators themselves. So here, knowledge of integration protocols and embedded systems becomes very essential to connect various components in the ADAS system effectively. You can start by actually doing projects or even courses in embedded systems or automotive engineering to start with, or to get a hands-on on these aspects. Now, the very important part again is AI and machine learning. Here, ADAS functions like example, object recognition, they rely heavily on AI/ML models. Now, start building foundational knowledge in neural networks, maybe computer vision and decision-making algorithms so that you can start understanding how AI enhances ADAS capabilities. So these are some of the skills which become very crucial in the current age to get into careers in ADAS. So one is programming. Technically, I'm talking about C++ as well as Python. And there's data analytics, there's AI and ML, and there's software system integration. Now, these are skills in terms of what you need to learn. The next one, which I feel is extremely important, is also the essential mindset for success in ADAS careers. I don't know how many of you would have actually known or seen this metaphor before. It's called the fish and fishbowl metaphor. Um, it's actually indicative of your transition from a college campus to a workplace. Now, you're, of course, moving from a place of comfort, familiarity, which is your college, to a very new environment geared up to take on new challenges. Of course, with time, you learn to adapt and grow as well. Now, here I've listed key mindset which I, as a leader, would look forward to, as well as I'm sure my peers in the industry also look forward to when we take in new graduates from college campuses. One aspect is curiosity and continuous learning. Let me tell you why it matters in ADAS specifically, because it's a rapidly evolving field in terms of technology as well as domain. Also, staying updated becomes extremely essential. You can start by following ADA's recent advancements. You can also engage in some open source projects and stay curious about new technologies. The next aspect is adaptability and resilience. Now, why is this really important? That is because when we look at ADAS development per se, right, it involves constant iteration, there's troubleshooting, there are even failures. Now, what happens is a lot of times we have to get into the zone of looking at setbacks as an opportunity to grow, as an opportunity to learn as well. Now, what here, developing a mindset that adapts quickly to changing technology as well as domain landscapes becomes all the more important. The next one is interdisciplinary thinking. Why I thought this is extremely crucial is that in ADAS, generally in automated driving or such projects or in this industry, the development itself combines elements of electrical engineering, there's computer science, and there's automotive design. Now, broadening your knowledge across these disciplines, fostering teamwork and a holistic approach to problem solving is something that becomes extremely important as well. There's another thing, proactiveness and initiative. On this aspect, I'd like to recount a personal experience myself. We had an intern who came to my team early on this year, joined us from a reputed engineering college in India. And what amazed me beyond his excellent programming skills is that his proactiveness and the aspect about initiative, taking an initiative. Although he was with us for just 3 months, the turnaround time for him to deliver topics or projects which were assigned to him was very minimal. He was extremely proactive in the sense that he was willing to learn new things. He learned them, he put these additional efforts, etc. So from that perspective, it left a lot of the seniors in the team as well very inspired and motivated, although he was a much junior engineering student in the team. Now, why do we value this? We value engineers who take the initiative and think ahead. Because as a leader, it is whatever, whether by tackling problems before they escalate and suggesting improvements. So this also gets very important. I will now move on to showing you some of the careers in ADAS itself. So it ranges from, maybe starting, you can talk about aspects like embedded software engineer, there is a control systems engineer, we have algorithm developers. So they technically design algorithms for all the ADAS functions like lane keeping, collision avoidance, etc. We also have roles like sensor fusion engineer. It actually combines data from sensors to create a complete environmental view. We also have system architects who design scalable, safe ADAS frameworks. We have, of course, validation engineers who are responsible for testing the ADAS features to meet the performance and regulatory standards. and to even check if the functionality is working as it is required to. And of course, we have functional safety engineers who develop the systems that comply with safety standards. And we have integrators as well as perception engineers as well. So these are some of the roles in ADAS, which actually range from an embedded software engineer all the way to system architects who have a complete view of the system itself. Moving on, I'll talk about some key aspects which become very important when you're trying to build a career in ADAS. So one aspect is hands-on experience. Try to already start as a student, whether you're in your fourth year or your third year of engineering. Try to start engaging in projects, build prototypes, or participate in hackathons, etc., to gain practical experience. You can also look at internships, probably internships in automotive or technology companies, which provide exposure to real world projects and industry standards. One more aspect is also look at certifications and courses. We have so many online options to learn now. Considering that, try to pursue certifications which could be in key areas like the automotive safety or also in specific technologies like Lidar or Radar. Now, one thing which I cannot deny is the importance of professional networks. You can probably start by joining industry forums. You can start attending conferences and also connect with professionals to stay updated on trends and innovations. I want to actually conclude this session by saying that the future of transportation is indeed unfolding, and your journey as innovators, creators, and leaders will surely drive it forward.
Yeah, that's a very
Yeah,
interesting overview, Hassini.
thanks, Jimmy.
So one question I have for you to begin with is, since you have been practicing in the industry for so long, is there any preferences for, which branch the student is coming from, or
Uh,
does that help, or is it kind of general?
yeah, Yeah, considering that we have the industry standards for the programming languages are C, C++, and Python, as I mentioned. And most of the times we take in embedded engineers straight out of college who have graduated in electrical engineering or electronics and communication engineering, because they tend to have these subjects in their fifth or sixth semester. They have electives in automotive electronics as well. So generally, it is electrical, electronics, etc., which work for us. But since I mentioned in ADAS itself, data analytics, AI, ML also becomes extremely important. So it helps if the students are able to, even if they are from electronics and electrical background, right? It helps if they are able to actually choose one of these data science subjects in one of the semesters as well.
That is interesting. So what preparation do you think you actually, yeah, in your talk, you have suggested participation in hackathons and
Right.
to pick up languages, but uh, from an automotive perspective, is there any preparation that these students can do as they're studying or as they are graduating from engineering in terms of looking at ADAS as a potential career option from a
Yeah.
knowledge perspective or an
Um,
experience perspective?
Correct. So when we talk about transitioning to a field of ADAS itself, I think strong understanding of automotive systems and technology, if it is possible for them to take the elective during one of their semesters, that would be great. Otherwise, individually also they can try to learn these domains, at least whatever is the basics that is required. And it goes without saying that proficiency in programming languages, right? In software development, um, having a good proficiency in C, C++, Python, or even aspects like MATLAB become very important. Other than that, what I have also observed is knowledge of sensor technology helps a lot, whether it is radar, lidar, at least knowing the basics of it before you get into the industry. Otherwise, the soft aspects, which is generally, sometimes probably not paid so much attention to, but becomes very important when they start working in the corporate structures, is problem solving, critical thinking skills,
Mm,
communication, aspects of teamwork. Example, we will be working with multidisciplinary teams, right? So
right.
having a good communication skill, having got to interact with multiple stakeholders, that's always a plus. Other than that, I think they should be open to continuous learning because it's an evolving field, the industry itself. So you should be committed to, or rather, one should be, including myself, committed to continuous learning. These are
Mm,
some things which will surely help.
excellent, excellent. I think that's a broad set, and I think it is more or less important across the professional
Yes,
segment, whether ADAS or not, I guess.
right. Yes,
That
definitely.
would be true, which is fair enough. So you talked about certain examples as you were explaining different automation levels. You gave some examples of Indian companies who have implemented some level one and maybe level two of ADAS. So how do you see? I've got two parts to my question. One is
Mhm.
from an overview perspective, how do you see ADAS progressing? We are
Mhm.
witnessing in US fully automated cars like Tesla has been operating,
Correct.
Waymo is operating, and they may be expanding scope. That is definitely going to happen. Uh, that is one. So globally, how do you see ADAS taking up, or the progression of ADAS from here? Second, in India, what do you see is the scope ADAS technology has for growth as far as Indian OEMs and Indian environment is concerned?
When we look at the overall, all over the world, when we say the ADAS market itself is projected to reach $63 billion, by probably the end of this year. We are already in the end of the year. So, which means that there is both regulatory, mandates as well as consumer demand for features like it would be ACC or the lane keeping assist or automated parking for that matter. Now, what becomes very important is technology advancements. Adoption of AI is becoming even more and more crucial now. Enhanced AI, ML, sensor integrations. That will make ADAS systems more accessible, is what I feel, across vehicle segments. With respect to India itself, or even other countries for that matter, where we have progressed much more when compared to India, regulations and standards, safety features like emergency braking, etc., right? They are becoming mandatory in Europe and North America, pushing automakers actually towards compliance. So these aspects are yet to probably come in India. That's where the faster adoption rate happens, not just consumers wanting to have cars which are fully automated or having more automated features, but from a regulatory standards perspectives, we have some way to go there. And
Mm,
the other aspect is consumer demand. Now, if you see in the last couple of years, there has been a growing preference of safety focused driving experiences. Right, this is actually making ADAS a key selling point even for mid range vehicles. So,
mm,
I think from the way we see it about how things are evolving, we actually see that one aspect is safety regulation standards. The other aspect is consumer demands. There's, of course, technology advancement and the market expansion. These are driving forces, whether it is India or in other countries. In India, we still have a long way to go in terms of when we can adapt to these.
mm,
Yeah. Also, I feel one challenge is as the market evolves for ADAS itself, right? Cybersecurity risks. Whenever there is a technology advancement, there is always a risk that comes along with it. And what I see is from a security perspective, cybersecurity risk or lack of standardization becomes a critical hurdle requiring urgent attention at some point of time.
true.
Yeah.
Shachi, do you have anything?
Uh, yeah, no, I think the overview was excellent. Like, uh,
Okay.
yeah.
So just one more question I'll just add here is, so yeah, I mean, Hasine talked about it in terms of the diverse skill set that is actually going into, the realization of ADAS as a concept. I mean, even small feature involves a diverse set of tech, so including embedded, you have mechanical, mechatronics, electronics, which are the physical components of, you have to, there's aspects of robotics, there is AI at a higher end,
Yes.
a lot of data. So I just want to understand one thing. So there's a lot of, as an overview and conceptual level, there is a talk of what we call as a software-defined vehicle, essentially, basically kind of a standardization of hardware versus customization of options, and a redesigning of maybe architecture around software itself,
Correct.
which is happening. So from a technical perspective, do you see what does that impact how ADAS progressing going forward in terms of with software taking the center stage and hardware getting standardized? Does that impact ADAS in any which way?
I would say whenever there is an advancement in a particular domain, right? Be it we're talking about ADAS, and then now we're talking about SDVs. Impact from point where okay, something majorly radical is going to happen with SDVs, that doesn't come into picture. Of course, there will be impact, but everything has its own pros and cons. And I think even with respect to ADAS itself, right? As much as possible, it is becoming important. There is more software in the vehicle that is actually driving the features of ADAS itself than the hardware itself. Hardware is surely required to the extent that it is required, but the intelligence that you build on it is always coming from software. So I see that more as a complement than having a negative impact, when you talk about these two aspects.
Cool.
Yeah.
That was good. I think this overview would have helped our students to really, get a picture of the ADAS aspect of automotive world.
Yeah.
And I think it's a very promising story which is shaping up, and it has been shaping up. I think there's enough room for a lot of talent, and there's a requirement of a lot of talent across the spectrum. As Haasine said, from algorithm development to verification, validation, training of models for ADAS itself. I think there's a lot of work which is required. And I think students watching this program should actually take a cue and a message from what Haasine actually shared in terms of skills and soft skills as well as technical skills that are required. I think she has put enough emphasis on that, for example, programming and preparing yourselves in terms of automotive architectures and understanding how automotive really works. I think, thank you, Haasine. That has been a very, very good overview, well prepared one. Thank you so much.
Thank you. Thanks for this opportunity and having me.
Okay, cool. So wish you all the best, and
Thanks, Chinmay.
thank you so much.
Yeah, thank you. Thanks, Shachi. Thanks, Chinmay. Bye.